Hello, my name's Bob Willis from Winnie TV, and we're here at SMTconnect. And I'm here with Dieter. And would you like to just introduce yourself, your position within the company, and the area of technology you're specifically involved with at the show?
Yes, thank you very much for being here. So my name is Detlef Beer. I am the head of the product development at the Viscom, and we are responsible for inspection solutions for AOIs and for X-ray systems.
Okay. And what's been the most popular area of technology that customers have been asking you about at this show?
I think for the moment it's really the transfer from 3D AOI to 3D IXI systems. So I think 3D AOI is common, and the technology that is mainly very popular and has a lot of benefits. And now we have really the possibilities to run 3D X-ray system as the inline speed. And also here are we offering a new systems which again offers you faster testing parts to be saving again additional seconds for X-ray inspection.
Okay, because obviously 3D inspection, true 3D inspection and measuring has been around many years, but not successful in many years. So what has driven you? Is it medical? Is it automotive? Who are the guys that are really driving the technology?
I think here is most demanding the automotive parts. So you really have to control the voidings for the heat sinks, and you have to control the voidings for the BGAs. And very new is also that you have to look at the power electronics. And especially here, when you're looking at the IGBTs, at the power modules, are there smaller void levels just allowed to be here safe for the long time reliability of the parts.
So in the power modules, approximately what void formation is allowed as a percentage, approximately?
Yeah, so normally you really have to separate the layers, and that's also the reason why you need 3D X-ray systems, because you have to check first on the die level, and there are very common just values of 2% of voids which are allowed. And when you're then going down to the DCB level, more we have than the cooler parts, then they're around about 10% voiding allowed.
So what capability would your X-ray system have to be able to guarantee to measure 2%?
Yeah, here is really a next large improvement that we are using AI technology. And so that means we are really taking the images and then checking with AI-supported algorithm to detect the small voids and separate these from the different parts from the normal soldering way. Sorry, just to continue here. And that means on the chip level, normally you have more or less than, I would say round voids, with looking like common voids. But when you're going down to the areas of the pin fins of the DCBs then you have additional, we call it fjords. So they are really looking very strange regions, and still you have to capture them safely.
So a lake, as you said, a fjord, as an example. Yeah, it's surprising. And when you're working with customers to inspect and then improve the process, what do you find is the most common reason for the voiding?
I think that's mainly a large input factor is here the kind of solder paste. So that's always interesting to take care about this, and that is keeping this in this kind of leveling. And another way is really to have a clean process, so that you also have no dust or anything else what are they're coming on different places here and mixed up here in the process.
Okay, and what do you see moving forward? I mean, you've obviously got to a level that you can achieve very successfully, but what's sort of the next thing, the next level, the next hurdle to cross?
As one real last change is that you're seeing that more and more the cooler parts, the pin fins part, are getting bigger, so that they do not only aluminum more, that more also copper parts, so that they have more cooling power, and that also is the need that you have to support it additional X-ray power. So that really needed 180 kV or more just to getting through the parts, to getting here a good X-ray image and to separate these parts.
Do you find it's fairly easy to train staff to use the X-ray machines and to understand the relationship between the criteria and then the information your machines are providing?
I think that is very important that you keep this always in mind and to check it here, and also that you have there any feedback loops and traceability parts that you're measuring the ways, and in general is the main part here that you use this information as a process indicator, because you never wanted to get too close to the defect level. So it's more important that you know you're in the safe range, and then when you see there's a change, that you can react as fast as possible before you are reaching the defect part. So here's very important really to monitor continuously these values and to check here the process.
And inline inspection is something that a lot of companies have tried to get to successfully, but obviously, as you described, you have been able to do that and also to do it at speed. So, I mean, just typically, just as a number, what sort of process time would you expect for, perhaps a board of this size? Sort of the processing and then out. What sort of time?
So it's always
an approximate.
I think that's a typical question. What is just available by some? Here's really the way that you have to, first of all, to check what is the resolution, what you are needed here. So what is the minimum time of defect? What is needed here, and what are included. But I think overall, you can inspect it in such a board in less than 20 seconds, including loading and unloading.
Okay, that's very respectable. Very respectable. I'd like to thank you very much for coming along and talking to us and introducing and talking about your advancements in your products.
Okay.
Thank you very much. My pleasure.
Thank you, it was a pleasure. Thanks.